going to look at frictional force. As usual, I'm going to explain the concept around frictional force for your understanding. Frictional force, or simply friction, is a force that opposes the motion of objects whose surfaces are in contact. So when you have two objects that are in contact, let's say a box and a table, now the force that opposes the motion of surface that are in contact is known as frictional force. So it means that if you want to move the object forward, frictional force is going to act in the opposite direction to oppose the motion. Now, friction is present in solids and also in fluid. Understand that fluid is a term that is used to refer to liquids and gases. So fluids are liquid and gases. Now, friction is present in fluid. Friction in solid is simply called friction or frictional force, while friction in fluid is usually considered as viscosity. So viscosity is fluid friction. Alright? Now understand that both solid friction and fluid friction depends on the nature of the object. What that means is that if you see a surface for solid, if you see a surface that is smooth, alright, friction is um, going to be lower there compared to a surface or surfaces that are rough. So friction depends on the nature of the surface. Same thing with a fluid. A fluid of a greater density is going to offer more opposition to the flow of objects or movement of objects than a fluid with a lower density. For instance, it is easier to move in water compared to moving in glycerin because glycerin is, or let's say bitumen, right? Bitumen or glycerin is going to offer more viscosity because it has higher density compared to water. So the nature of the substances, the nature of solid or the nature of fluid depends on how much frictional force that's going to be experienced in them. All right. So, but we can make a dichotomy. We can make a difference. Fluid friction depends on the area of surfaces in contact. This is very important. But for solid friction, all right, this is supposed to be solid friction. Solid friction or friction in solid does not depend on the area of the surfaces in contact, right? I can use a formula to um, buttress that. Friction in solid is usually written as frictional force is equals to coefficient of friction. This is a Greek letter called mu. It is coefficient of friction multiplied by normal reaction. So this is the formula for friction in solid. So the formula is frictional force is coefficient of friction multiplied by normal reaction. While friction in fluid, right, fluid friction is usually written as this is coefficient of viscosity multiplied by the area multiplied by velocity gradient. While velocity gradient is equals to velocity over linear length. All right. So you can see that fluid friction depends on the area of surfaces in contact. While for solid friction does not depend on the area in contact. So that is the dichotomy. That's the difference between solid friction and fluid friction. Now, in this video, what we are going to consider properly, or what we are going to focus on, is solid friction. Um, Another video is going to be done on fluid friction. So let's get to solid friction. All right. Now, for solid friction, I'm going to categorize them into cases for better understanding, right? And I'm going to consider two cases which we have the horizontal surface, right? Frictional force concept when object is placed on horizontal surface or moving on horizontal surface, then friction concept when objects are placed or moved in inclined surface. So let's start with horizontal surface. Now, when an object is placed on horizontal surface, a force can be applied on it horizontally or inclined. So let's consider the first case when the force is horizontal. So let's say you have a rough surface, all right, and an object is placed on a rough surface, a rigid object, a solid object, right? Mind you, a solid object is an object that is rigid, that is, its boundary can withstand a shearing force. So it has a definite shape. While a fluid cannot withstand a shearing force, the boundaries of a fluid cannot withstand the shearing force. So a fluid will take the shape of the container. So we're talking about rigid object in this case, right? That is a solid object. Now let's say you apply a force to move this object horizontally. Let's say this is the force. Because friction opposes motion, right? Frictional force is going to act in opposite direction. So let's say this is frictional force. Now, because this object is sitting on horizontal surface, its weight is going to act vertically downward. So this is going to be the weight, and understand that weight is equal to the product of mass and gravity. Now, according to Newton's third law of motion, if we have a force, there's going to be an opposite but equal reaction. So let's say this is the reaction, R, right? Some people call it Fn, that is normal force. They mean the same thing. So now what we'll do is to resolve these forces, right? We have the upward force, we have the downward force, and we have the horizontal forces. So let's resolve them. So resolution of the forces, right? Now let's begin with the vertical force. So for the vertical force, since the goal is to move this object horizontally, right? The object is not moving vertically, so there is no acceleration for the upward motion. So what it means is that your weight must equal to R, and R is going to equal mg. So this is the resolution for the vertical force. All right. So understand that when an object is placed on a horizontal surface and an horizontal force is applied on it, the normal reaction is equals to weight, which is equals to mg. That means we can write the formula for friction, because earlier we said that solid friction is equals to mu r, so that's going to equal mu mg, which is coefficient of friction. Now, for the horizontal force, for the horizontal force, um, we have force being applied. Frictional force is in the opposite direction. Understand that when two forces are acting in opposite direction, their resultant is going to equal to the subtraction. That is, the resultant of forces that are in opposite direction is obtained by their differences. So the resultant force is going to equal to F minus Fr, and also note that resultant force is equal to the product of mass and acceleration, right? According to Newton's second law. So that means you can say that F minus Fr is equal to ma. So these are the concepts you need to know for this first case, right? That is, let me put them together. When object is sitting on horizontal surface, the normal reaction is equal to mg. Then resolution of the horizontal force is F minus Fr is equal to ma. All right. I hope you get that and that makes sense to you. Now let's consider another case. Now, what if the force is not horizontal? What if the force is inclined? That is, you have an object placed on horizontal surface, a rough horizontal surface, but the force applied on it is inclined at an angle. Let's say angle is theta to the horizontal. So this is the force, right? The force is inclined. So how do we do this? How do we resolve this? First, since the object is on horizontal surface, the weight is going to act vertically downward, right? Then the normal reaction is going to be in opposite direction. That is, it's going to act vertically upward. So this is going to be normal reaction or normal force. Now, when a force is inclined, that is, you don't have a force acting normally, that is, it's not acting at 90 degrees to the object, you have to resolve the force. So this force has component now. This force has a component in a vertical component, which you're going to call Fy, and then that's an horizontal component in this direction, which we're going to call Fx. Now, since this is the opposite side to the angle, this side is going to equal F sine theta. Now then, since this side is the adjacent, this side is going to equal F cos theta. All right, you should know that already. So now again, the goal our goal is to move this object horizontally. So the component of this force that is moving the object horizontally is the horizontal component of the force, which is Fx, or also called F cos theta. So what we'll do is to resolve the forces. So let's do resolution of the forces. And now let's begin with the vertical. All right. So for the vertical forces, now how many vertical forces do we have? We have three, right? Weight is the vertical force acting downward. Normal reaction is the vertical force acting upward. Then also Fy is the vertical force acting upward, that is the vertical component of the force applied. Now, since the goal is to move the object horizontally, that means the vertical forces must balance each or one another in this case. So it means that the upward forces must equal downward forces. So what are the upward forces? Fy is an upward force because it's acting upward. Now your normal reaction is also an upward force, which must equal to weight, which is the downward force. Now our formula for frictional force is mu r. So let us solve for r. So r is going to equal W minus Fy. Then r is going to equal, W is weight, which is mg. Then Fy is F sine theta. So this differentiates the force, the case of inclined force from horizontal force. Now, for inclined force, it means then that our formula for frictional force is going to equal to mu r. Now, our r is not mg now. Our r is mg minus F sine theta. So for this case, our Fr is going to equal mu into mg minus F sine theta. Alright, so for inclined force, when an object is placed on horizontal surface and then you have an inclined force, your frictional force is going to equal to this. Now let's resolve the horizontal force. For the horizontal force, what horizontal force do we have? Since this object is going to be moved forward, right, frictional force is going to act in opposite direction. And then we said that since they're acting opposite direction, to find their resultant, the resultant is going to equal to MA. The resultant force is going to be the difference between the two forces. So we're going to have Fx minus frictional force is equal to MA. So Fx in this case is F cos theta. So we have F cos theta minus frictional force is equal to MA. So this is the resolution for the horizontal force that you should bear in mind. All right. As we move on, you're gonna understand better. So let's see another case. Now, the other case that you can have is inclined surface. The cases that we have looked at before is when an object is placed on horizontal surface. But now let's see a case in which an object is placed on an inclined surface. So inclined surface is different from inclined force. All right. Inclined force talked about how the force is being applied to the object. But for inclined surface, the surface in which the object is lying itself is at an angle to the horizontal. So let's say this object is placed at an angle theta to the horizontal, and then this is how the object is. So this is different from the last case, and then it has a particular concept that you must fully understand. Now understand that when an object is placed on horizontal surface, right, the object is just going to act, the weight of the object is going to act vertically downward. But if you tilt this object, that is, you raise its surface up a little bit, okay, the weight is also going to shift, right? It's not going to act vertically downward again. It's going to tilt by the angle in which you raise the level. So it means that the weight of this object, because it is center of gravity, all right? So the weight of this object, when it's placed on an inclined surface, is not going to act vertically downward, but it's going to act at an angle, okay, to the vertical. So this right here is going to be the weight of the object. So let me take it out so that you can understand better. So this is the weight of the object. It's going to act at an angle to the vertical. So theta to the angle to which the surface is raised. So this is the weight. but a normal force is always acting perpendicularly. So in this case, your normal reaction or normal force is now going to equal to the vertical component of the weight, because when the weight is acting at an angle, all right, it's going to have component now. It's going to have horizontal component and vertical component. So this is the vertical component of the weight. So let's call this Wy. Then this is the horizontal component of the weight. Let's call it Wx. So your normal reaction, R, is going to equal to the vertical component of the weight, Wy, because your normal reaction must act perpendicularly. It must act at a 90 degree. So your normal reaction is going to equal Wy, that is the vertical component of the weight. Now, how do we get the vertical component of the weight? Now, look at it. This side, Wy, is the opposite side. Sorry, this should be Wx, I meant to say. So this Wx is the opposite to the angle. So it's going to equal to W sine theta. Then Wy, this side, is the adjacent to the angle. It's going to equal W cos theta. So what it means is that in an inclined surface, your normal reaction is W cos theta. Always bear that in mind. That is how inclined surface differ from horizontal surface. For horizontal surface, your your normal reaction can either be equal to the weight or weight minus F sine theta if the force is inclined. But for inclined surface, your normal reaction is most likely going to be W cos theta, except a force, an inclined force is applied on it, right? You understand better later. So our R is W cos theta for this case. Bear that in mind. Then again, the other thing I want you to know is that your weight has an horizontal component, okay, which is parallel to the plane. So understand that whenever you are doing inclined surface, always bear in mind that you have a force which is directed downward to the plane, and that force is W sine theta, all right, such that if no force or if no other forces is applied on this object, if you raise this surface enough, this surface is going to slide, or this object acting on this surface is going to slide down. The force that is responsible for this object in an inclined plane to slide down is the horizontal component of the weight, which is W sine theta. All right, so always bear in mind that W sine theta is always present in an inclined surface. All right, so I will leave it there for now, because for an inclined surface, you can have different scenario of question. That is, you can have a scenario in which the object is on inclined surface and the force is applied, and a parallel force, so another force is applying downward, right? You can have inclined surface, an object on inclined surface in which a force is applied downward. You can have inclined surface in which a force, an inclined force, right, is applied to the object. So I don't want to explain all of that because we are still going to solve questions on them. So when we solve questions on them, it's going to be clearer to you. So what we'll do now is to start solving question, all the concept that we've learned. Let's start solving question so that you can understand better. But if you have not fully grasped everything that I said, just go back a little bit, rewind, watch it again, understand all the concepts, then you can come to solve question. So coming to solving question, before I solve any of the question, you can pause the video first, try and solve it using the concept that you have learned, and then you can then see the solution right after. Let's go. Now, we have that an object of mass 80 kg is pulled along a horizontal surface, rough ground, by a force of 500 Newton. Find the coefficient of static friction. Now, before I continue further, let me say emphatically that coefficient of friction, that is, I would say that formula for frictional force is mu multiplied by normal reaction, where this mu is called coefficient of friction. So, coefficient of friction, number one, is a dimensionless quantity, that it has no unit. Why? Because it is a ratio of similar quantity. Any quantity in physics or in science that is a ratio of similar quantity is going to be dimensionless. Okay, is dimensionless. That is not going to have a unit. So your mu does not have unit, doesn't have dimension. Then again, your mu can be of two types. You can have coefficient of static friction, which is the coefficient of friction present when the object is just about to move or not yet moving. So the frictional force that is present when you have coefficient of static friction is also called limiting frictional force or static frictional force. So when you say limiting frictional force, it refers to static friction. Now, if the object is moving already, all right, it is called coefficient of kinetic friction or coefficient of sliding friction or coefficient of dynamic friction. Understand that most often than not, coefficient of kinetic friction is usually greater than coefficient of, no, it should be the other way around, pardon me. Coefficient of static friction is usually greater than coefficient of kinetic friction, most often than not. All right, so having said that, let's go ahead and solve this. So let's try and picture it. An object of mass 80 kg, so let's say this is 80 kilogram object, is put along a horizontal floor by force of 500 Newton. So 500 Newton. So this is the force, right? Find the coefficient of static friction. Of course, we know fully well that weight is going to act downward, normal reaction is acting upward, then frictional force is in the opposite direction, right? Static friction means that the object is not moving yet. What it then means is that the acceleration of this object at the time in which the force is applied is equal to 0 meters per second squared. That is why it is static friction. Now, remember we said that our F minus Fr must equal to ma for this case. What it means that F minus Fr must equal to mass times 0. Then F minus Fr is going to equal to 0. Then frictional force is going to equal to F. And the force applied is 500 Newton. So frictional force is equal to 500 Newton. Then again, we said that for this case, your R is equal to weight, which is equal to mg. So our R is going to equal to 8e times 10, because we are given G to be 10, so R is equal to 800 Newton. Okay. Now we said that frictional force is mu times thermal reaction. We are looking for coefficient of static friction. So coefficient of static friction is going to equal to Fr over R, which is going to equal to 500 over 800, which is 5 over 8. And 5 over 8 should give 0.625. 0.625. No unit is dimensionless, we said it before. So it's make choice D the correct answer. I hope that makes sense to you. Now, next question. A boy pushes a 500 kilogram box along the floor. So it's pushing, push. So the force is this way. So let's say the force is this way. So this is the force. The weight is 500 kg. All right. If the velocity of the box is uniform. Now, this is a very important concept in physics. Understand that uniform velocity, okay, is equal to zero acceleration. All right. Why? Because acceleration is change in velocity over time. So uniform velocity means that final velocity and initial velocity is the same. So if v and u is the same, it means that v minus u is t. So v and u is the same. So we can say v minus v over t. V minus v is going to equal to 0. 0 over t is going to equal to 0 meters per second square. So note that whenever you have your velocity to be uniform or constant, acceleration is equal to 0. All right. So now the question is, what is the coefficient of friction between the box and the floor? We are looking for coefficient of friction, but the force is 2000 Newton. So this force is 2000 Newton. Frictional force is going to be in opposite direction. weight is acting vertically downward, then this is our normal reaction. So now we said that for the horizontal force, F minus Fr is equal to ma, but then acceleration is equal to 0, so it means F must equal to Fr, and that is equal to 2000 newtons. All right. Then again, for this case, your weight is equal to normal reaction, which is going to equal 500 times 10, which is 5,000. Why? Because your weight is equal to mg and your r is equal to weight. Now, coefficient of static friction now, or coefficient of friction, but because in this case, this is going to be kinetic friction. So coefficient of kinetic friction must equal to frictional force over normal reaction for this case. So coefficient of kinetic friction is going to equal to frictional force is 2000 newtons. The normal reaction is 5,000. So this is going to equal 2 over 5. So what is 2 over 5? So 2 over 5 should give 0.4. So coefficient of kinetic friction equal 0.4. And that's going to make choice D the correct answer. Next question. Now, this question says that a body of mass 50 kg is given an initial speed of 5 meters per second on a rough horizontal floor. If you slide on the floor for 3 meters before it stops, calculate coefficient of kinetic friction between floors. So let's try and picture that. Let's say this is the rough horizontal floor. Then a block of mass 50 kg is given an initial speed. So you make this to move, so it's moving, but then it stops finally at this point. What is making it to stop is, of course, is frictional force. So the force applied on this object, that is the frictional force, makes it to stop. But then we are told that it has covered a distance of 3 meters. So here to here is 3 meters. Now we are looking for coefficient of kinetic friction. Understand that coefficient of kinetic friction, as we said before, is going to be frictional force over normal reaction. Then since weight is acting vertically downward, this is normal reaction. So our normal reaction R is going to equal to mg. So normal reaction equal to m is 50, the mass is 50, g is 10. So normal reaction is going to equal 500 newton. Now that means our next job then is to find frictional force. So how do we find frictional force? Understand that the force on this object is just frictional force because it's sliding. No other force is applied. So all the force, or the only force on this object, is frictional force. So it means that that frictional force must equal to the product of mass and acceleration. That's the only force that we have in this case. We are not told that any force or any other forces is applied on the object. The only force on this object is frictional force. So for us to find frictional force, we must find the acceleration. So how do we find the acceleration? Now we have to employ the concept of motion that we learned in the last video. Mind, if you have not watched the video, please go back and watch the video that we did on motion so that you can understand better. So the object is coming to rest. It means that v must be equal to 0 meters per second. Its initial speed is 5 meters per second. Then the distance covered is 3 meters. So we're looking for acceleration. So now we have to look for which equation of motion has all these parameters. That is v squared equals to u squared minus 2as. Why are we using minus? Because it's a deceleration. So it's going to be negative. So now v is 0. 0 squared is equal to 5 squared, right? Yes, u is 5. 5 squared minus 2 times a times 3. So 0 squared equal to 25 minus 6a. So 6a is going to equal 25 because we move it to this side. So a is going to equal 25 over 6. Now we can now find frictional force. So frictional force is ma. So that's going to give 50 times 25 over 6. All right. So what is 50 times 25 over 6? So 50 times 25 over 6. 50 times 25 divide 6. That's gonna give 208.33. So frictional force equal 208.33. Now we can now find coefficient of friction. So mu k is gonna equal 208.33 over normal reaction, which is 500. So this divide 500, and then if you put your answer in form of fraction, you're gonna get 5 over 12. 5 over 12. Right, now you can do this another way. Since you know fully well that frictional force, sorry, coefficient of friction is Fr over R, which is Ma over mg, because the frictional force is the only force, is going to equal to Ma. Then your R is mg, so this is going to cancel this. So we calculated acceleration to be 25 over 6. Then g is 10, so multiply by 1 over 10. That's going to give 25 over 60. 5 in 25 is 5. 5 in 60 is 12. So the answer is going to equal 5 over 12. That is the shortest way to solve it. I just have to explain this to you so that you can understand why frictional force is Ma, and then you can get it better. Next question. This question says that a load is put at a uniform speed. So look at that term again, uniform speed. So whenever you hear uniform speed, what should come to your mind is that acceleration is equal to 0 meters per second squared along a horizontal floor by a rope. Now we have another case now. This is a different case. This is a case of inclined force. Okay, but on horizontal surface. So by rope inclined at 45 degrees to the floor. Okay, so we have this 45 degree to the floor. I'll make this 45 degree. Right? Now the force in the rope is 1500 Newton. So this force here is 1500 Newton. What is the frictional force on the load? Right? So since you are pulling it along the horizontal floor, that is, the body is being moved along the horizontal floor. So the direction is forward. Frictional force is going to be in opposite direction. All right, so we are looking for the frictional force. So we don't need to do too much. We know fully well that we just resolve the horizontal forces. All right, this force as component is going to have a vertical component and horizontal component. So the horizontal component Fx is equal to F cos theta, right? So this is going to equal 1500 cos 45. That is the value of Fx. Then if you resolve the horizontal forces, Fx minus frictional force must equal to Ma, and we have established the fact that acceleration is equal to 0. So Fx minus Fr must equal to 0. Then frictional force must equal to Fx, which is 1500 cos 45. So what is 1500 cos 45? That is 1500 cos 45. That should give 1060.66 newtons, which is approximately 1061 newtons, which makes choice D the correct answer. Now this is another problem, and now we have come to the problem of inclined plane. Now we are being told that an object slides down an inclined plane at an angle of 30 degrees. So we have a surface which is inclined. This inclined at an angle of 30 degrees to the horizontal. What is the coefficient of static friction? So whenever static friction comes into play, understand that acceleration is equal to 0 meters per second squared. Why? Because the force that is applied on this object is not sufficient to move it, right? It's not sufficient to give it acceleration. That is why it's static friction. It just move it a little bit, but not to give it acceleration or to get it moving. But we are told that the object slides down, okay? But what we are concerned about is static friction, not kinetic friction. So acceleration is equal to zero, right? So remember I told you that when you have an object this way sliding down, the first thing that you should establish is that one, your normal reaction is equal to W cos theta. And I've explained why. Because the weight is not going to act vertically downward. The weight is going to act at an angle at which the surface is tilted. So, and then your normal reaction must equal to the vertical component of this inclined weight. So this is the horizontal component. Your R is equal to the horizontal component of the weight. So in this case, your R is equal to W cos theta. Then again, we said that there's a force parallel to the plane, that is the force that is directed down the plane, and that force is W sin theta. And with the way this question is fashioned, the only force on this object, or the force that is making this object to slide down, is this W sin theta, and that's the only force on this object, and that's the only horizontal force that we have. All right. Then we said that resolving the horizontal force for resolution of the horizontal, right? So the only horizontal force that we have is W sin theta. Then W sin theta must equal to MA, all right? But W sin theta is the only force that we have. Now, frictional force, since this object is sliding down, frictional force is going to act in opposite direction. So let's say this is frictional force. Um, pardon me, we have two horizontal forces actually, W sin theta and frictional force, because we are asked to look for static friction. So frictional force is present. So the horizontal force that we have is W sin theta and frictional force, pardon me. So how do we resolve the horizontal force? Since they are in opposite direction, it means that Fr minus W sin theta must equal to ME. Then acceleration is equal to 0. So Fr minus W sin theta must equal to 0 because acceleration is equal to 0. Then Fr is equal to W sine theta. Then Fr is equal to W. We are not given W sine theta, so let's just leave it that way. W sine theta. We are looking for static friction. Understand that formula for static friction, mu s, is frictional force of a normal reaction. Now, what is frictional force? We got it to be W sine theta. The normal reaction, we said it is equal to W cos theta. So W is going to cancel W. Coefficient of static friction then is sin theta over cos theta. Sin theta over cos theta in math, if you are familiar with trigonometry, is equal to tan theta. Alright? Sin theta over cos theta is tan theta. So what it means is that coefficient of friction must equal to tangent of 30 degree. And what is tan 30? Tangent of 30 degrees is equal to 0.577, which is approximately 0.6, and choice D will be the correct answer. All right. Please grasp that. If you don't, just rewind and then watch again. I'm sure you will understand. Next problem. A body of mass 10 kg rests on a rough horizontal plane whose angle of tilt is variable. Now, which angle of tilt theta is variable? Theta is gradually increased until the body starts slide down at 30 degree. Coefficient of limiting friction, right? So look at the word limiting friction. So limiting friction is equivalent to static friction. So in a way, we are looking for coefficient of static friction, right? So I believe this is practically the same thing as what we did in the last question. It's just fashioned another way. So this object is on an inclined plane. Then so it's an inclined plane, and then it just starts to slide down when the angle of inclination is 30 degree. All right. But now we are given the mass of the object. So the mass of the object is 10 degree. Now, since it's going to slide down, we've established that the force that is responsible for making it to slide down is W sine theta. Then frictional force is going to act in opposite direction. All right, since it's static friction or limiting friction, acceleration is going to equal 0 meters per second squared. So then we're going to say that for the horizontal force, W sine theta minus frictional force must equal to 0. Then frictional force is equal to W sine theta. Then again, our normal reaction R is W cos theta. So coefficient of static friction is going to equal, W is 10, but we don't actually need to put there because it's going to cancel out. So we're going to have mu s is frictional force over normal reaction. Then we're going to have W sine theta over W cos theta, which at the end of the day is tan theta, which is tan 30. So coefficient of static friction is going to equal tan 30 is 0.58. So choice is the correct answer. Next problem. A body of mass 2 kg is placed on a rough inclined plane whose angle of inclination is 30 degrees. So let's quickly draw that. Inclination is 30 degrees, right? Find the resultant force acting down the plane and the acceleration if the frictional force of 5 Newton acts between the body and the surface. So this is sliding down the plane. Okay. So let's say we have an object this way. The mass is 2 kilogram, right? Now we are to find the resultant force acting down the plane. So direction of resultant force is down the plane. It means that frictional force is going to be upward because frictional force opposes the motion. So we are told that resultant force, let's call it RF, is down the plane. Don't not forget that we said that when you have an object in an inclined plane, your W sine theta, which is due to the weight of the object, will act downward. So we have W sine theta acting downward. So we have to look for resultant, right? Find the resultant force acting down the plane if a frictional force of 5 Newton. So this frictional force is 5 Newton. Okay, so we have to look for the resultant force now. So what it means is that to look for the resultant force, we have to know the forces that we have. We have frictional force, we have W sine theta. So this resultant force must equal to W sine theta minus frictional force. All right, because W sine theta is acting downward, frictional force is acting upward. Now, the reason why the resultant force is acting downward is because W sine theta is greater than frictional force. Let me explain something to you very quickly. Let's say you have an object this way, and then you have this force acting this way. Let's say this force is 50 Newton, and then you have another force this way acting to the left, it is 10 Newton. Now, the resultant force is, of course, is going to be equal to 50 minus 10, which is going to equal 40 Newton. But what will be the direction of the resultant force? Will it be to the right or to the left? Of course, it's going to be to the right. Why? Because your 50 Newton is greater than 10 Newton. So the resultant force is going to be in the direction of the force, the greater force, which is to the right. So in this case, the resultant force is acting downward because W sine theta is greater than frictional force. All right. So for us to get the resultant force, what we need to do is to subtract W sine theta and frictional force because W sine theta and frictional force are acting in opposite direction. But the direction of the resultant, okay, is in the direction of W sine theta because W sine theta is greater than frictional force. So resultant force now is going to equal, what is W? W is mg, of course, sine theta minus frictional force. So resultant force is going to equal 2 times 10 times sine 30 minus frictional force, which is 5 Newton. So resultant force is going to equal 20 sine 30 minus 5. So 20 sine 30 is 10 minus 5. So the other force is going to equal 5 Newton. So the other force is 5 Newton and it's acting downward. Next question. Find the force parallel to the slope required to move a body of mass 2 kg up a slope inclined at 30 degrees to the result with an acceleration of 2 meters per second. If the force between the two surface, if the final force between the surface is 10 Newton. So let's try and put it in picture. Okay, manage this. So this is inclined at 30 degrees to the horizontal. So we are looking for the force that is required to move this object up the plane. Okay, find the force parallel to the slope required to move a body of mass 2 kg up the plane. Alright, parallel to the slope means that this force is an horizontal force. So this force is unknown, but we have frictional force. Frictional force is 10 Newton. Understand that frictional force is going to act in opposite direction. So this is frictional force. Then again, for an inclined plane, you have a force which is W sin theta that is acting downward. Always remember W sin theta whenever you are dealing with the cases of inclined plane. So W sin theta, which is due to the weight of the object, is always acting down the plane. So we're going to have W sin theta down the plane. So these are the three horizontal forces that are acting on this object. Now we have to look for this force. So now, resolving the horizontal forces, your F is upward, your frictional force and W sin theta are downward. So it means that your F minus W sin theta plus frictional force, because they are in the same direction, so we must add them and then subtract them from F because they are opposing force now must equal to MA. Alright, you need to understand this. This is very important. W sin theta and frictional force, they are in the same direction, so we sum them up, but they are against the motion. Alright, so we have to subtract it, two of them collectively, from F because they are both against the motion. The motion is upward, W sin theta is against the motion, frictional force is against the motion. Another way to represent this is to say that F minus W sin theta, because W sin theta is against the motion, minus frictional force must equal to MA. I'm sure that this should make sense to you. So we now have, since we're looking for force, let's solve for force or make force subject of formula. So we have MA plus W sin theta plus frictional force. So the force is going to equal, what is the mass? Mass is 2 kg. We are given the acceleration to be 2, so 2 times 2 plus 2 times acceleration to gravity, let's take it as 10. Angle of inclination is 30, sine 30 plus frictional force is given to be 10 Newton also. So F is going to equal 2 times 2 is 4 plus 20, 2 times 10 is 20. 20 sine 30 times sine 30 is going to give 10 also. Then plus 10. So 4 plus 10 plus 10 is going to give 24 Newton. So that force must equal to 24 Newton. Alright? Understand that. And then if you don't, just rewind and then listen again. Now we'll come to the last question. So this is the last question for this video. We are going to solve more questions in the next video. Now, question says that a body of mass 4 kg is on the point of slipping down a plane. So inclined at 30 degrees. So this is the plane. The plane is inclined at 30 degrees. It's on the point of slipping down, right? And we know that the force that will make it to slip down is, of course, our W sin theta. Now, which force parallel to the plane? We just move it up the plane. So we are looking for an upward force. Now, this question is a little bit tricky. Why? Because we are not told if frictional force is present. Then again, it wasn't mentioned that this plane is smooth. So, except you are told that a plane is smooth, do not assume that frictional force is not present. So we assume that frictional force is present. Now, if frictional force is present, since the force is directed up the plane, then frictional force is going to be in opposite direction. So frictional force is going to be directed down the plane. right? Now, um, so a body is on the point of slowing down, which is clear that which force prior to the plane will just move it. So when you say will just, it means that acceleration is still equal to 0 meters per second squared, because will just means it's not sufficient to give it acceleration. That is what will just mean. Right? So take note of that. So whenever you hear the word with just or just enough, it means acceleration is equal to 0. Now, resolving the horizontal forces, we have F minus W sine theta plus frictional force must equal to MA. Acceleration in this case is equal to 0. I have to put this in parentheses. So F minus W sine theta minus FR must equal to 0. Now your F is going to equal W sine theta plus FR. So now F is going to equal, what is the force? What is W, I mean? W is mg, so we're going to have 4 times 10 multiplied by sine 30 plus, what is Fr? All right, remember we said that Fr is mu r, and then whenever you have this case, your mu is always equal to um, cos theta. Sorry, tan theta I meant. So mu is tan theta. So we are going to have Fr is mu r. So we have tan theta multiplied by r. R in this case is mg cos theta. So we have mg cos theta. So this is going to equal to 40 sine 30 plus, now we have tan theta cos theta. Remember we said that tan theta is equal to sine theta over cos theta, right? So that means we can say that we have um, tan theta multiplied by, sorry, let me write tan theta as sine theta over cos theta multiplied by mg times cos theta, so that cos theta can cancel cos theta. So we have f naught equals to 40 sine 30 plus mg, m is 4, so 4 times 10 is also going to give 40. Then we have sine theta left here, 40 times sine 30, so which is same thing as f equals to 40 sine 30 plus 40 times sine 30 is all right, let's just simplify. 40 times sine 30 is 40 times 0.5 is 20 plus 40 times sine 20 is also 20, which is going to give 40 newtons. So the force that is needed to make it stay up the plane is equal to 40 newtons. All right. So this is how you solve cases like this. So please go over this video. You may need to watch it twice, 3 times for you to absorb everything that is needed in it. But I believe that we have done justice to this. So what you need to do is find more practice questions to do. You can join our Telegram page. We give you more practice questions on this, and then in the next video we are going to solve some more advanced questions, college first year college questions, to give you a better understanding. So thank you for watching this video, and please, um, if you have learned anything, do well to subscribe, to like the video, to share, and then come back, because we are going to teach a lot of better concepts, um, fast and great understanding for you, so that you can become better. Thank you. I'll see you.